Now that we've seen what an orthographic camera can do for us, let's see how to create, manipulate, and apply one. In this demo, we've got a game world with a huge star, a tiny planet, and an itty-bitty satellite. Let's see what this looks like without using a camera. Using the default camera, we can just barely see the edge of the star. We can see just half the planet, and we can't even see the satellite. It's actually right here, but it's so small it's not even 1 pixel wide. So let's use an orthographic camera to zoom in on each one of these objects in turn.
So what is a camera? Well, a camera holds on to two matrices. One matrix encodes the camera's position and orientation in the game world. For 2D games, this is usually just a simple XY pair. But for 3D games, say a 3D flight simulator, the camera can hold the plane's 3D position, its pitch, its roll, and its yaw. The other matrix encodes how the camera translates positions in the world into positions on the screen. This includes how much perspective to include, that's fisheye lens versus telephoto lens, and how big an area on the screen the camera will ultimately draw to.
To use a camera, we first need to declare and initialize it. Then there are two things we have to do down in the render callback. The first is calling camera update. Whenever we adjust the properties of a camera, like its position, it needs to fold those changes into the matrices that define how it looks at the world. The easy way to ensure this happens is just to call update each frame. It's a fast operation, so no worries. The second thing we need to do is to tell our shape renderer that we want to use our camera. We do this by setting the shape renderer's projection matrix to the camera's combined matrix. The combined matrix is the combination of the camera's view and projection matrices. Yeah, there's a lot of matrices flying around. Basically, Shape Renderer doesn't have a notion of position in some larger worlds, so all it's got is a projection matrix. One more thing is we need to handle screen resizing correctly. The resize callback gets called right after create and anytime the screen size changes, which could be because a mobile device rotated or because we're running the desktop app and the user is changing the window size by dragging around the corner. When the screen size changes, we need to make sure our camera is updated. If the camera thinks that the screen is smaller than it really is, shapes will be way bigger than we want them to be, and vice versa. This call, set to ortho, updates the camera with the new screen size. The first argument is whether an increasing value of y should mean going down the screen, and we don't want that to be true. Alright, let's see what code it'll take in order to get the camera to zoom in on each of these objects in turn.